Let's solve an application question. A ship leaves port at 1 p.m. and sails in the direction north 34 degrees west at 24 miles per hour. A second ship leaves the same port at 1:30 p.m. and sails in the direction north 56 degrees east at a rate of 20 miles per hour. How far apart are the ships at 3 p.m.? Round to one decimal place. What is the bearing to the nearest degree from the first ship to the second? Well, the first thing we need to figure out about this problem is what we mean when we say north 34 degrees west or north 56 degrees east. Well, those are actually what are called bearings. And if you just imagine a compass, north above south and west always on the left. All right, north, south, west, east on a compass looks just like that. What this bearing, north 34 degrees west, means you start thinking that you're at the north, but then you lean 34 degrees towards the west. So it's that angle that we're dealing with there being 34 degrees. The second bearing we're given in this problem, again thinking about north, south, west, and east, is north 56 degrees east. So again, you just think about starting at the north, but then leaning 56 degrees towards the east, and then that's that bearing. Our ship's traveling in that direction. Well, just to be sure that makes sense, let's think about south 10 degrees east, and just make sure that one's not part of our problem, but let's just make sure we can all draw that bearing. So we'd imagine going south, but leaning 10 degrees towards the east. Oh, and let's just do one more together, just for good measure. South, 89 degrees west. So we think about heading south, and then almost going a right angle, almost due west. That's how we manage and deal with these bearings. Now, bearings traditionally are written with south or north out front, and then you're going one way west or the other way east. And sometimes you'll actually hear people say 89 degrees west of south, and that would mean the same thing. But for us, this is the way we're given the bearings, so that's what we're going to deal with. So let's see if we can get a diagram going for this problem. So we have a port. I'm just going to go on at the port, give myself a little compass with a north, south, west, and east. I have a first ship that sails away on a bearing north 34 degrees west. So that was this one, where my 34 degree angle's right there. All right, that was ship one. It's moving 24 miles per hour that way between 1 o'clock and 3 o'clock. So that's a 2-hour long trip at 24 miles per hour. That side length, that distance we've moved there is 48 miles. And I think that's going to be useful information. Ship 2 gives ship 1 a 30-minute head start. It leaves at 1:30 and then sails on the bearing north 56 degrees east. So we lean 56 degrees this way. And I think I'm going to have to rethink how long that side is. But right away what I notice is I have a 34 degree angle and a 56 degree angle. And let's see, yep, that's a right angle between it. My ships are running perpendicular to each other. All right, but that's only a 1.5 hour journey because it left 30 minutes later. So at 20 miles per hour, let's see, well, that's going to be 20 times 1.5, that's only going to be 30 miles. So let's back that down a little bit because it's not quite as far out. That's a 30-mile distance. And now I see a right triangle that I'm dealing with. How far apart are the ships at 3 p.m.? Well, all of a sudden, I see a right triangle problem. Right, I'm really looking for that distance, and I can just use the Pythagorean theorem to do it. 48 squared plus 30 squared is equal to d squared. Bring in my handy TI-83. All right, let's take a square root. D is the square root of 3204 3204 miles. And if I was going to leave this exactly, I'd simplify under the radical, but I was told to round to 1 decimal place. So I'll just report this as 56.6 miles. Oh, because I was asked a question in words, I think I should write an answer down in words. At 3 p.m., the ships are about 56.6 miles apart. All right, now I'm asked about a bearing. A bearing from the first ship to the second ship. So now I need to think about a compass out here where the first ship has ended up, right? Still north, south, west, and east. And I'm drawing a bearing, right? I'm thinking about what the bearing here is. So I think it's going to be a south something leaning towards the east. And I need to know this angle right here. All right, so I have to figure that out. And I think if I knew this angle in the triangle, I would be all right. Let's see if I can make this picture just a little bit larger with all of the information in it, because I think it's getting lost in the little camera here. So that's this distance. And here's the side of my triangle. And a little right angle here. All right, and I know this angle. Excuse me, I don't know that angle. I know this angle is 34 degrees. Well, if I follow that up here, that means this angle actually has to be 34 degrees. Those are alternate interior angles. They have to be the same. And so if I can find that little triangle angle right there, I'll be in good shape. And I know that that's a right triangle with a side that's 48 miles and another side that is 30 miles. So I'm going to find that angle alpha. Tangent of alpha would be equal to 30 over 48. And so I should be able to find that using inverse tangent, tangent inverse of, well, let's see, that's 30 out of 48, that'd be 5/8. So inverse tangent of 5/8. Just giving myself a little less to deal with. I have made sure that I'm in the degree mode. Inverse tangent of 5/8 comes out to be about 32 degrees. The angle all the way across there would be that 32 degrees with 34 more. So that's going to be about 66 degrees. The bearing from ship 1 to ship 2 is about south 66 degrees towards the east. And we found our bearing.